Our next video lecture topic here, we're going to continue on with synovial joints and talk about some synovial joint classification. And these synovial joints can be divided up into different categories based on the shape of the articulating surfaces between the bones and the movements that are allowed at those joints because of the shape. So there are 6 types that we're going to talk about. You've got plain synovial joints that are called plain joints or planar joints. Hinge, pivot, condyloid, saddle, and ball and socket. Hopefully condyloid is reminding you of condyle from the anatomy section of Unit 3. We talked about several condyles. All right, so let's take a look at some examples of these different types of joints. I do want to point out to you that within Chapter 8, there are terms that are used to describe joint movements, things like flexion and extension and adduction and abduction, and you are more than welcome to read through that and start learning that information now. I'm going to cover that when we go over the muscular system. Because when we do the skeletal muscles, we're going to be learning about when those skeletal muscles contract, which bones are they pulling on and which joints are they causing motion to occur in. And so at that time, we'll learn the different names for joint movements. But you're more than welcome to learn that now, and if you're reading along in your textbook, they are going to be using that terminology. I just wanted to point out that I will be coming back to that information from Chapter 8 when we move on over to Unit 4 and study the muscular system. Okay, the first type of synovial joint we're going to discuss, plain joints. And an example of a location in the body where you have plain joints would be the intercarpals, so between your carpal bones and the wrists. And if you look at those carpals pretty closely, you notice that the articulating surfaces there are flat or kind of shaped like a plane. So these bones basically just slide across each other, and those are the types of motions that they make. Now these are synovial joints, so those flat surfaces there between those carpal bones are wrapped in a joint capsule, and you have synovial fluid there, and you have ligaments, and you have tendons there as well. So even those little bitty joints like that will have those features that we talked about with synovial joints. All right, the next type of synovial joint is called a hinge joint. And an example of a location where you have a hinge joint is at the elbow. So hinge joints, all right, so what they're showing you here on the diagram is hinge joints are a type of joint where you have rotation around one axis. So if we can imagine an imaginary line passing through the center of the joint like that, a hinge joint is going to rotate around that axis. So this type of joint is also called uniaxial. And a good example, again, the elbow joint. When you flex, this is called flexion of the elbow, when you're bringing the forearm bones upward towards the humerus. So that's a hinge. That joint is functioning like a hinge. Where else do you have hinge joints? The knee joint is a hinge joint. The joints between your individual phalanges and the fingers, those are hinge joints. And if you think about it, you can only move the bones at those joints around one axis. There's only one type of movement that they do. So those are called hinge joints. And they're showing you some other examples. Well, I guess they're not actually, because they're just showing us the arm. So they have not highlighted. They should have highlighted the joints there between the phalanges and the fingers as other examples of uniaxial type joints or hinge joints. All right, the next example of a synovial joint that we have here is a pivot joint. So pivot, you guys know what pivoting means. Something rotates around this way or that way. It's pivoting. And a great example of a pivot joint is the proximal radio-ulnar joint. So without ever having seen the name of that joint before, we should be able to figure out where that's located. So it's proximal, and we're talking about the radius and the ulna. So that's going to be the joint between the radius and the ulna, and it's proximal, so it's going to be up near the elbow rather than down toward the wrist. So because the radius has that round head, the radius is able to rotate. All right, so think about if you're standing in anatomical position, you guys know that you can rotate your forearm around that way. So when you do that, that is a pivot type motion, and that is occurring as the head of the radius rotates this way around that portion of the ulna. So that pivoting type motion is also a uniaxial type motion because you're pivoting around just one axis. We have an imaginary axis running there through the center of the joint. So that's another type of uniaxial joint as well. All right, the next type of synovial joint we're going to talk about is a condyloid joint. So that sounds like condyle, where you have, remember condyles, you have a curved rocker type surface. Good example of a condyloid joint, the metacarpophalangeal joints. Metacarpophalangeal joints. Can we figure out what that means if we break it down? Metacarpo, that's referring to your metacarpals, and remember those are your palm bones, the bones in the palms, they're not finger bones. And then phalangeal is referring to the phalanges. So this is where you have a joint between a metacarpal and a proximal phalange where they come together. The shape of the bones at those articular surfaces, one of them has kind of a bowl shape like you see right there, and then the other one has a condyle type shape, a rocker, and then they fit together. And these types of joints are considered to be biaxial. This is a biaxial type joint, which means they can rotate around two axes. All right, and so these are your knuckle joints, are condyloid type joints. The knuckles of the fingers are condyloid type joints. And so let's think about the motions you can do with your knuckles. You can go up and down like that, and you can go like this. You can move the bones that are articulating there from side to side. So up and down, side to side. So when you're going side to side, imagine an axis like this passing through the top of the knuckle. You're moving the joint, the bones at the joint around that axis. And when you go up and down, imagine an axis running through the joints like this. So you're going above and below, above and below. You're rotating around that axis. So those are considered to be biaxial joints because you've got two different axes there that you can rotate the bones around. All right, then your thumb, all right, so where you have the joint between the, back down in here where you have the joint between the metacarpal of the thumb and one of the carpal bones down here in the wrist, you've got a specially shaped joint there that has a saddle-like appearance, like you see over here on the side. And this is called a saddle joint. And this is similar to a condyloid joint. It is biaxial, but because the shape is a little bit different, where you don't have with the condyloid joints, you have the oval shape on one bone and you kind of have a bowl shape on the other. With this one, you can see you have a saddle shape on one bone, and then the other bone forms a kind of a C-shaped structure that fits down into the saddle. So this is a special joint shape that you have between the metacarpal that's attached to the thumb and a carpal bone down here in the wrist. And because of its shape, this is the bone that allows us to have opposable motions between our thumbs and our fingers. It allows us to grasp things, and that gives us a lot more ability to manipulate things with our hands than other types of primates that are not able to do that. And I think, let's see, the condyloid joints include all of your knuckles, including the thumb, where you have the proximal phalange where it meets the metacarpal that's attached to the thumb. That's still a condyloid joint, just like you have at your other fingers. The saddle joint is where the metacarpal meets the carpal, one of the carpals down there in the wrist. That's also considered to be a biaxial type joint. You can make movements around two imaginary axes passing through a saddle type joint. All right, and finally a ball and socket joint. Now ball and socket joints are considered to be multi-axial because you can rotate the bones at these joints around many different imaginary axes through the joints. So examples of those: shoulder joint. Then where else do you have a ball and socket joint? Hopefully you're thinking of the hip joint as well, where the head of the femur fits into the acetabulum. That's another ball and socket type joint. So if you think about your shoulder, you can move your shoulder around in many different ways, up and down, around to the side, just about any angle you want to. So because of that, it is considered to be a ball and socket joint, and the joint is literally shaped like a ball and a socket at both of those locations. Hip joint, you also can move the femur versus the os coxa around many different imaginary axes. Of course, you don't have quite the flexibility at the hip joint that you do up at the shoulder joint. All right, so that was just kind of an overview of how we can classify those different synovial joints according to the shapes of the articulating surfaces and the range of motion that they have, you know, the number of axes that you can rotate the bones around at those particular joints. The next video lecture, we've got two more. The next one, we're going to talk about some additional features at the knee, shoulder, and hip joints, since those are the joints where people tend to have the most problems. And then the last lecture, we'll talk about some joint disorders, and then that will finish up our Unit 3 physiology.